So I'll sort of explain the the title of the talk will become evident as we go. So I'll start with this sort of idea of first, who am I? Why am I here? If I were to kind of go over to my website and find a nice way of explaining who I am, I would probably say something like this. I'm a computational cognitive scientist, or sometimes I call myself a mathematical psychologist. And what I'm interested in is how does the human mind work? And how do we learn new concepts? How do we reason about unknown situations? Because I'm interested in that, I've ended up thinking quite a lot about statistical methodology and how it applies in behavioral sciences. And as my career has gone on and I've gotten older, this has started to cause a certain shift towards a data science orientation. So here's how that transition has happened. I've always been a psychologist by training, though in some sense of the term, I'm an outlier as psychologists go. My research has focused on this notion that we can think of the human mind as some kind of probabilistic learning machine. So we're trying to think about statistical learning tools, but rather than looking at learning from data generally, we're looking at whether these things can be used as explanations for why humans make the judgments we do. So I tended to write papers that looked like this. I'd write a Bayesian account of the detection of novel categories. And this is partly me showing off, look, yes, I do know how to do Bayesian non-parametrics and things like that. But really, the interesting aspect to this is what I can learn about the human mind. So I present people with lots of weird looking stimuli that I've carefully crafted so that people's judgments about them would give me some hints as to what underlying classifier is being used for humans to make their decisions, right? So some psychological models look like linear discriminant classifiers, others look like kernel density things. There's lots of different accounts out there. So I will collect some data. I get stuff that looks, gives me these nice, pretty pictures like this. So I've got data from lots of conditions. Some models work, other models don't. In the appendices to the papers, I provide nice proofs that, yes, under no parameterization can this model do blah, 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 blah. This kind of thing is quite common in a very, very small part of the psychological literature, but it's not generally the way that psychology works. This has accidentally led me to start writing papers that have nothing to do with human behavior directly. So I will write stuff on, fast and accurate calculations for first passage times in linear diffusion models. That's not obviously a psychological phenomenon, but first passage times are of interest when you need to think about how humans make decisions under time pressure. So, you'd write papers and again, look, lots of equations. Yay, that's so much fun. Nobody in psychology likes the equations, but I feel the need to put them in sometimes because, look, there's an audience who actually likes equations. But let's not be bothered with the particulars. Every now and then, doing this kind of work leads you to do things that actually have pretty pictures and are kind of interesting. So here's an example of a project where we were trying to think about what is the large-scale structure of human semantic representation. So you'd give people just really simple word association games. So I say cat, and you have to say whatever word comes to mind first, and that might be dog. If I say statistics, it might be fun. Okay, maybe not, but let's pretend. And if you get several million judgments like that, you can start putting together representation. You can put together large-scale semantic networks, and so it'll produce things like this that unfortunately tell you that most people don't associate statistics with fun, but you might be more likely to have, I don't know, so let's do cat and dog, and hopefully, there we go. So this is just putting together a little visualization that's sort of working out what is the local semantic network around these concepts. And this gives you these nice, pretty pictures. So I like showing this one off in talks. The structure of these networks is of particular interest to us in understanding how the human train of thought kind of operates. Okay, so because I've done this kind of work as an empirical scientist with bits and pieces of psychological theory in there, I've spent quite a bit of time wondering then about the statistics we use to analyze these data. And I've ended up in a strange place. So as middle age has hit me, I've started asking myself as a scientist what problems we're solving by doing this kind of research. And I end up writing papers then about the potential tensions that exist between the judgments a scientist needs to make and the judgments that a statistical model selection procedure makes. And they're not always giving you the same answers. I spent a bit of time thinking about what we mean when we want to talk about reforming scientific methods or scientific practices. I spent a bit of time thinking about when it is useful to mathematize or formalize our underlying theories of things and when it's not. So I end up, writing things in papers that say things like this, the estimating the future performance of a model with regards to data collected via unknowable experiments is likely impossible, which sounds very depressing, and in some ways is, but it's trying to reflect the point that when we measure model performance, say in terms of like cross-validation or simple methods like that, we're very often measuring something that the scientist doesn't care about. The scientist cares about future data from related but not identical generative processes, and that's really hard to assess. So we're often getting measures of performance that are not the same thing that the scientists care about. What's worse is that on the other end, the scientist has a tendency to want to just simplify things. So we often build statistical or theoretical models that are defined with respect to toy worlds. So we, at some point, says, let us assume that data are IID, at which point everybody starts laughing, because of course none of this is true. And this has consequences then for the differences between what the models predict and what human behavior looks like. The same principle applies with experimental designs. If you design away the complexity of the real world, then you end up with theories that don't actually match particularly well. So this has led me now to start realizing that we need to be pushing a lot of what we do into more realistic applications. And this has started making me think about questions like, how does research get out there into the wild? And this is one of my favorite examples of how my research has failed to get out into the wild. Specifically, this is the code release for one of the papers I referred to slightly earlier. It is a screenshot of MATLAB code presented in Appendix C of an Elsevier paper that is not open access. This is the worst possible way to share anything. Like, I can't run a screenshot. Most people can't look at this. The only reason that this particular algorithm turned out to be useful is that somebody else took it and turned it into an R package. And this stuff starts to matter. So I've been thinking a lot about how to make the tools that we sort of developed through these theoretical processes more accessible Danielle, and user-friendly. Yep.
Just 1 minute.
Okay, good. That's about right, I think. What this has ended up leading me to do is think a lot about visual design, writing software, stats textbooks, creating public access slides, putting things up on YouTube, writing engaging blog posts, the sort of thing that is not traditional output, but I think we ought to be taken more seriously as academic output. And so even though a lot of the work is now thinking about how do we make things pretty, how do we make them easy to engage with, one of the big points I want to make is that the usability, the cuteness, and so on is not in conflict with the seriousness or the substantive nature of the works that we do. And that's everything.